Good morning. This is a tutorial to show how to access the modeling outputs using the OpenDAP interface with MATLAB. So right now I'm on the DRI website at the scripts location, and I'm going to scroll down in the modeling section, which is this one over here, the first one. I'm going to scroll down all the way down to where it says MATLAB tutorial and open to access OpenDAP. So there's a little toolbox that we've created. So the first thing, I'm going to click there and try to download this file. So I'm going to go here and say download. It always asks me this thing, but I just want to download the file. I'm going to save it on disk, and at this point I'm going to exit this particular browser. And in my download section, I have essentially this zip file. So at this point, I'm going to extract the zip file. I'm going to create a folder, and for the time being, I'm going to drag it on the desktop here. At that point, I'm going to go and fire up MATLAB, and here I am in MATLAB. In my screen here, I'm going to go onto the desktop. I'm going to go into this DRI folder, and inside this DRI folder, there are several files. Some of these are functions that are needed to load the data, which are these 4 functions here. And then there's a main function example, which is this example OpenDAP. So I'm going to edit this one here. We're going to look at this one in particular. And so here we have it in the editor. So the first thing that we see, of course, is we have to have this particular toolbox in our path. So if you don't have it, you can add it with the add path if you need to. The next thing is we're going to browse the catalog of the OpenDAP server for the type of output that we're interested in. And so to do that, we go back onto Firefox. This is our DRI site. So here, for example, we have a table of all the runs on the OpenDAP server that are currently already posted. So we can click on one of them over here. And so here you have the full list. And so I'm going to pick the first one. And so for each of these runs, you essentially have the name of the run, which is pretty much self-explanatory. And then for each run, you have a set of grid, boundary condition, initial condition files. And then you actually have a link to the entire output. So I'm interested in the output for now. So I'm going to click there, and here I have a string that looks like a netcdf file, but a URL to a netcdf file, which essentially concatenates all the output files. In fact, I can click on this one, and I can also browse online all the variables that are contained in this file. But all I'm interested in MATLAB is this string here. This is really the string or the URL of this netcdf OpenDAP connector. So I'm going to copy that, and I'm going to go back to MATLAB, and I'm going to put that string into my file where it says here, assign the file containing the variables of interest. Once I have that, I can go in my MATLAB and execute this particular code. The first step is to load the horizontal grid and compute the vertical coordinate system. So we're going to do this particular part here. I'm going to copy and paste it in MATLAB. And this may take a little bit because you're downloading through the internet some large amount of data, and so we're going to wait for a second. And once this is done, we should have a set of arrays. The first array is this GRD array here, which contains all the grid information, and then ZR, ZW, and HZ, which contains essentially the vertical coordinate system. So in particular, ZR is the depth of the S-coordinate system at the so-called density points or row points. ZW, again, is the vertical coordinate system depth, but it's located at the what's called the vertical velocity points, which are located in between the row points. And HZ is the thickness of each of these terrain following layers. Now, if we look at the variable GRD, which is the grid, it has a whole bunch of information, including what these parameters here that represent essentially the stretching of the vertical coordinate system. And then you have longitude, latitudes, masks, angles, and so forth. So once we've loaded that, at this point we're going to load what time arrays are available. So we're going to load these time records. I'm going to do evaluate selection. And so once again, when you load the time records, ROMs, this particular model uses seconds. since 1991-01. So I'm going to convert that into some kind of MATLAB format using the datenum. And so now I have year, month, and day. And so, for example, in this particular run, this is year 2009. The month are all 11, and the days, of course, sorry, day. We're going to have a whole slew in this case, going forward. At this point, let's do an example of selecting a certain space and time location where we want to extract a profile. So here, for your convenience, I set a coordinate here. This is longitude and latitude, minus 120 west, and this is 34 north. And so I'm going to find the closest IJ location to this. So this is kind of a rough kind of MATLAB code. I'm going to find the IJs of this horizontal location that are closest to this point, and then I'm going to select a whole bunch of times that I want, say from record number 30 to record number 40. And of course, these can be selected based on the time array, depending on what you're looking for. And then last, I'm going to extract the depth at those locations with this depth. So let me do that. Evaluate selection. And so now we have a whole bunch of depths here for that particular location. Again, ROMs, this is a particular shallow location, 700 meters. And in ROMs, in the S coordinate system, the depth are kind of upside down. So the last record is the surface, or at least close to the surface, is 0.6 meters. And the first record is the bottom. So you need to remember that. At this point, what we're going to do is we're going to extract a profile and make a plot of these profiles from, say, record number 30 to record number 40. So I'm just going to execute this code again, evaluate selection. And so this is, for example, the first profile. In this case, I'm only plotting temperature. So you can see it here. And if I go in my MATLAB window, this is a do loop, just for you to play with that. You can go through the loop and plot many stations. But in this case, I'm just plotting the first one. And so the last example is if you wanted to, for example, plot the sea surface height. Again, this is the command to read from this netcdf files. We're going to execute this, evaluate selection, and then we're going to plot it onto that particular figure, which is over here. So let's clear the figure, and then let's plot it there. Oops, sorry. Unfortunately, I pasted the wrong thing. So let me just copy this again and paste it. And here you got the free surface. So these are just some very basic functionality examples. We will be expanding this by providing also additional functionality like extraction of full vertical sections and so forth. But this at least can get you started on basic exploration of the ROM's output from the DRI modeling. Thank you very much.